Good morning, children. This is class 12th physics, chapter number 5, magnetism and matter. Today we are going to cover the topic that is magnetic field of Earth. Now, children, we know that Earth has magnetic field, but how can we prove it? So, let's talk about a simple experiment. So, suppose here we are having a bar magnet and we have freely suspended the bar magnet. So, we know, children, that after some time the magnet will come to rest and the magnet align itself along the north-south direction. Right. Even if we displace the position of the bar magnet, it will arrange itself along the north-south direction. Right. So it means that there is some torque acting on the bar magnet, which is forcing it, which is aligning it in the almost north-south direction. So children, here, here also, and we know that if we place a bar magnet in external magnetic field, then a torque acts on it and it turns or it aligns the bar magnet in the direction of magnetic field. So here also children, there is a torque which is acting on the bar magnet and it is aligning it along the north side direction. So it means here also there is some external magnetic field and that magnetic field is Earth's magnetic field. Now let's talk about the magnetic field of Earth in detail. So children, here we should be knowing some terms. That is, the first term is the axis along which the Earth rotates is known as the geographic axis or the rotational axis, right? And perpendicular to this axis, the line which divides the Earth into two is called equator. Now, along the geographic axis, there are two poles. That is geographic North Pole and geographic South Pole. Now, the north and south of Earth, they are defined using the geographic North Pole and geographic South Pole. Now children, suppose this is your freely suspended bar magnet. So we know it will align itself in almost north-south direction. But here it is seen that it aligns at an angle of 12 degree with the geographic axis. Actually, it should have aligned like this along the geographic axis, north-south direction. But the bar magnet, it aligns making an angle of 12 degree with the geographic axis. Means it is aligning itself along some other axis, and this is the axis along which the Earth's magnetic field exists. So the Earth's magnetic field, it exists along the axis which is known as the magnetic axis, which is at an angle of 12 degree with the geographic axis. Okay, so this is the axis, magnetic axis, along which the magnetic field of Earth exists. That is making an angle of 12 degree with your geographic axis. Right, children? So Earth's magnetic field is along this magnetic axis. It is along this magnetic axis. Now, children, let us assume that along this magnetic axis, we are placing, let us assume there exists an imaginary very big bar magnet like this. Right, this is along the magnetic axis. Now suppose the Earth's magnetic field is due to this imaginary bar magnet. Right, now let us define the north and the south pole of this imaginary big bar magnet. Now children, we know that here we are having a small bar magnet. Now this is the north pole. right? As it is after freely suspended, it aligns itself in this position. It means that there must be some south pole over here which is attracting the north pole of the bar magnet towards it. Similarly, as here the bar magnet's south pole rests, it means there must be some south pole, then the south pole of the big imaginary bar magnet north pole should be here, which is attracting the south pole of the freely suspended small bar magnet. It means that this is the south pole and this is the north pole of this big imaginary bar magnet. Now children, here we can see these are the magnetic field lines, right? Okay. These are the magnetic field lines. So the magnetic field lines, they are along the magnetic field lines, they are from the north pole to south pole, right? This is known as magnetic north pole to magnetic south pole, right? So this is your north pole of the big imaginary bar magnet, right? That is known as the magnetic north pole. This is the south pole of your big imaginary bar magnet, which is placed on the magnetic axis. That is known as magnetic south pole. So children, the magnetic field exists from magnetic north pole towards magnetic south pole. Yes, you can say like that. Or children, you can say like that the magnetic field exists from, it is opposite for this. See children, it is from geographic south to geographic north, right? And if it talks in terms of magnetic, it is magnetic from magnetic north towards magnetic south. So don't get confused. Just clear the concept over here, right? So we should be knowing now few terms, that is magnetic axis. So magnetic axis is when a freely suspended magnet, right? It rests, it comes to rest. It aligns itself in north-south direction. So the line joining the north-south direction, the north-south poles, at that position is known as your magnetic axis, right? Geographic axis, this is axis around which the earth is rotating, so that is your geographic axis. And we know that the angle between the magnetic axis and geographic axis is 12 degrees. Now this is a new term, that is magnetic meridian. So magnetic meridian, children, that is a plane which is passing through the magnetic axis. So magnetic axis is the line through the north-south pole of the freely suspended magnet. So this is the plane that is passing, that is along the magnetic axis. And geographic meridian, that is children a plane that is passing through the geographic axis. That is the line along which the earth is rotating. Okay, so magnetic meridian and your geographic meridian. Right children? Now